Hello and welcome back. In this video, let's discuss about single point of failure. A single point of failure is part of a system that if it fails, will stop the partial or entire system from working as expected. There's a good chance that your website relies on third-party libraries to provide you with extra functionality. Tracking scripts, A/B testing, and advertisements are just a few of many reasons why you would want to use a third-party library. The problem is that if the library that you use is hosted on another server, you risk creating a single point of failure. If for any reason the server that is hosting these libraries goes down or is slow to respond, your site will unfortunately be affected by this. A user visiting a site that is undergoing a single point of failure is likely to have a very bad experience. The page would appear blank or incomplete. Nothing on the page would respond to interactions like scrolling or clicking, and the time will be wasted. Sites that go down due to a single point of failure are seen as less reliable, untrustworthy, and undeserving for a return visit. Few websites correctly implement defensive techniques to handle single point of failure. In such cases, these failures are gracefully handled. In this video, let's understand how web page test helps to diagnose single point of failure problems and how we can overcome them. In order to simulate single point of failure using web page test the site as you normally would, but you'll need to ensure that the domains of the third party are blocked. The first step is to identify third party resources. You would run a test normally using web page test and analyze the domains that the website is interacting with. Once you understand the list of domains that you are interacting with, you can distribute them into two buckets. One, domains which you have full control. Two, domains which you do not have any control. Once you understand those domains, we can simulate a failure for those domains. To simulate a failure, WebPageTest provides a feature called as black hole server. A black hole server creates a mechanism where all the traffic could be diverted where the request gets dropped. Once the request gets dropped off, we could analyze the impact on the UI. And once we know the impact on the UI, we can take appropriate actions and come up with a backup plan. So in this case, we'll pick up website under test, pick whatever test location and browser of choice you want, and start a normal run. I would call this as normal and kick off a normal run. Now let's understand the test results. In this scenario, we have not blocked any resources, so the site loads normally. Now that the test is complete, let's understand the different domains Airbnb interacts with. Click on domains, and we get a clear breakdown of all the domains Airbnb interacts with. We have a domain name and the number of requests made for each domain. We also have the domain name and the number of bytes we actually exchange from each domain. If you observe, this is the domain that is making a bunch of calls. Majority of the calls are from this particular domain. So let's try to recreate a scenario where if this particular domain is down, how would Airbnb respond? For that reason, copy the domain that we want to inject single point of failure. Now go back to your test, pick up the same URL, where I'm only interested in the first view, a label of single point of failure. In the single point of failure section, provide the domain that you want to block. At this step, all the requests that goes to this particular domain are rerouted to blackhole.webpagetest.org, which in return drops all the requests, ultimately replicating a single point of failure. Now let's observe what would be the outcome of this. Let's click on Start Test. WebPageTest is smart enough to create two flavors of the test for this. A flavor where the domain is not blocked and the other flavor of the test where the domain is blocked. It gives a comparison of both blocked versus unblocked. If you observe, the original test is completed, but the single point of failure is still going on. We'll get to the details of why the single point of failure is taking more than expected time. Once the test is complete, you'll be landed on the page where WebPageTest provides a comparison between the two test runs. The first thing we'll do is to set the thumbnail interval to 1 second. The top film strip basically provides us the results of an original test, which means nothing has been blocked in this particular run. All the domains are available for Airbnb to download and display. On the second film strip, we have blocked a particular domain. What's happening here is that when everything is available, Airbnb downloads all the resources, renders, and provides the page. So at 7 seconds, pretty much the site is done downloading and the user can experience it. On the flip side, we have blocked a very critical domain which is required for Airbnb to display the UI. In this case, Airbnb is waiting for a resource to be downloaded. Since it is unavailable, it cannot proceed. There might be some timeout behind the scene, and it might be waiting for that particular timeout. But this would result in a bad experience for the end user. If you notice, until 32-second mark, the user is just displayed a blank page. On the 33-second mark, the user is displayed a page which is bare minimum. This is how we basically replicate single point of failures. We can go back to the team and come up with a mechanism of how we could gracefully handle if that particular critical domain is not available for any reason. Working on single point of failure, your site is robust and resilient for any kinds of failure, ultimately providing the user the best experience ever possible. Hope you enjoyed this video. Thank you.